Okay, so far we've talked about limits. We just had a little bit of an introduction to limits, if you recall, and we said that a limit was basically the y value that approaches that a function approaches as x gets closer and closer to a number, right? Well, now we're going to extend that idea of limits and look at it in terms of infinity. Okay, what happens to a function as my x value gets closer and closer to infinity? Well, what does that mean if I'm getting closer to infinity? That means I'm approaching a very, very large input. Okay? So we'll be looking at functions as x gets really, really large, and this symbol means infinity. Okay? If there's nothing in front of it, we can assume it's positive infinity, and if there's a negative in front of it, we can assume that it's going to be a very large negative number. Okay? So we'll extend this idea of limits to finding horizontal asymptotes. Okay? So normal limits, we've talked about normal limits where x approaches a of f of x. Right? So that's normal limits. Well, now when we look at limits at infinity, the only thing that changes is this little value right here. Okay? We end up with the limit as x approaches infinity or negative infinity of f of x. So we're going to have some function, and we're going to look at how the y value changes as the input gets larger and larger. So you can see where this is going. We've talked about horizontal asymptotes before, and how a function approaches a certain number. Some functions have horizontal asymptotes because they approach a certain number as you get larger and larger values of x. Okay? Alright, so let's take a look at an important limit that you will be required to remember, and that's this limit right here. The limit as x approaches infinity of 1 over x. Well, what's 1 over x? Okay, our function here is 1 over x, okay, and that is the rational function, if you recall, and it looks like this graph right here. Okay, as I get closer and closer to 0, I end up with an asymptote here, and as I get closer and closer, as my x gets larger and larger, the graph tends to get closer and closer towards the x-axis. Right? This is the x-axis. This is the y-axis. Okay, and so that's just the graph of this that you need to remember. And if I were to make a table and plot the points, this is what I would see. Okay, obviously this is not drawn perfectly to scale. If I had 1 here, I would expect to see 1 right there. As x goes to infinity, this means as x approaches infinity. That means as x approaches infinity. Okay, approaches. The limit as x approaches infinity of 1 over x approaches 0. Okay, the limit gets closer, the y value gets closer and closer to 0. Okay, remember that the limit is talking about the y value. What's happening to the y value of this function as I change my x? And so you'll see that it gets closer and closer to 0. The y value right here would be pretty high. At 1, if that was 1, okay, this is not drawn to scale, but that would be the y value would be 1. As I move over here, my y value is getting smaller. As I move out to bigger and bigger numbers, my y value keeps getting smaller and smaller. Okay? Same thing as I go towards negative infinity. If I start putting negative values in, and I start putting larger and larger numbers, you're going to see it get closer to 0. Okay? So here's the main idea. The limit as x approaches infinity of 1 over x is 0. Okay? The limit as x approaches infinity of 1 over x is 0. And that makes sense. If I were to just use regular limit algebra, okay, if I just by substituting, if I just put 1 over infinity, well, what's 1 over a really big number? I'm going to get 0. Okay, that's going to be a really small number. Okay, so that's just the introduction to limits at infinity.